Sorry. Yes.
Spill over.
Spillover.
Yes. Sir, it is in lecture third week 2.
Okay, so we will discuss it during that time because as of now we are going lecture by lecture, right? So maybe some students who are interested in that part, they will join in week 3 or week 2 as we are talking. So it will be better if we discuss it in week 3 only.
So what we discussed today?
Today we have some problems on population forecasting and few theoretical based questions.
Okay, but it is not in that course, environmental sciences.
Sorry, in what?
Uh, it is not a topic in environmental sciences.
It might be actually, I need to see the course, but it should be.
Okay, actually, I am the student of environmental sciences, so I have joined the lecture for that.
Okay, so you can share your that this particular question in the chat box. So if it's fits into today's agenda, so we can discuss it quickly. Otherwise, it's better to like switch to the particular week where this particular question will be
Okay,
more relevant.
okay. One thing more, will you please explain passive solar energy?
Yeah, passive and active.
Yeah.
Just give me a moment. These are all actually topics of that time, na, when solar and all those will be discussed. Okay. Okay, so basically passive and active. I just quickly Googled it because whenever these particular topics are more relevant to these solar energy related weeks, still the passive and active, if you look at the definition anywhere, active solar heating, please mute yourselves, whosoever are joining. So we will start the questions by around 6:05. So this active solar heating, basically what they do is that they directly captures the infrared radiations or solar radiations coming from the sun and converts that energy or uses that energy. On the other hand, passive solar heating that has been used in various cases, what they do is that structure steering heater without the heat of mechanical devices. I will show you a figure that will be more helpful.
Okay.
Just give me a minute. Yeah. In this particular picture, you can see on the right hand side there is passive, on the left hand side there is active. So in active, you can see that they have employed directly solar panels to capture the solar radiation, solar energy, and then convert it into electricity or heating devices. On the other hand, passive solar systems, they are basically installing windows or orienting the direction of doors and ventilations and windows in such a way so that you can get the maximum amount of that solar radiation.
Okay, sir.
Here it is given passive solar emission depends on pattern, structure, construction of a home rather than external sources. On the other hand, active is what when you're using your solar panels or those collectors, concave shaped discs for concentrating the solar radiations and all. So those are more like active solar systems.
So in passive solar energy, we do not use solar panels, but in
No,
active solar energy, we in active solar system we can use solar panels.
right.
Okay. तो पैसिव इज नेचुरल लाइट की तरह हो गया ना कि नेचुरल हीट नेचुरल लाइट हमने उसको डायरेक्टली इन्वायरमेंट से ले लिया.
True. In a way that we are, for example, if you are orienting your house in such a way that during winters, let's say during the construction of a house, you have oriented it in such a way that during winters, the place where you are going to spend most of your time, that should face the sun during the daytime, so that maximum heat can be absorbed by the walls and all. So at least during the daytime, there will be minimum requirement of heatings and all. Same goes for your lights as well, lightning, because you increase the size of windows so that you can trap in more solar light, so that during the daytime at least you don't need to use artificial bulbs and tube lights and all those stuff.
Okay. Sir, in near future, can we make a home which are revolving, or we can shift the whole floor towards the solar energy or
Yeah,
air?
these are already present. I think there are few structures, few kind of homes who have already done things like this, that they can revolve it, and so in a way that the site that they want, or the rooms that can receive the maximum solar radiations. I think there are some examples, you can Google that.
Okay.
If I
Thank
find
you.
something, I will be we will be starting our session at 6:05. So in the meanwhile, I will also Google something if I can find some examples.
Okay. So this is a session for applied thermodynamics.
No, no, this is a session for your environmental science, and I think this particular week's questions, this is mostly on population forecasting and whatever you were taught mostly in week one by Professor Sudha Goyal.
Okay, okay.
So we are going week by week. So as the topics keep on changing, subsequently the kind of questions in these live sessions, they will also change accordingly.
So will you please, last time you say you can told me that the exponential growth.
Yes, yes, I
Yeah,
have that.
yes.
So I have discussed with the TAs who are working with ma'am on this particular question. So I think you got the answers of 164 point something, right?
Sir, 164.
Yeah,
Sir,
in op
according to that problem, I have got an answer 2718, but I don't know how I get it.
okay, so the correct answer is actually 164. What were the values? 100, I think, was P naught.
Sir, it is the PO.
Huh.
PO, PO is 1000, rate 10%, time 10 years.
PO is 1000,
Rate
uh,
is 10%,
10%, okay,
time is 10 years.
10 years. Thousand. हाँ हाँ The value of P should be 100, not 1000. And in
Oh,
question number 6, the question was P0 or P naught, as we call it. It is not P0, it is P naught. That is the initial population. It is 100. The
oh,
growth rate is not 10, it is 0.05 or 5%. And they have asked what should the population be after 10 years. So that is the actual question. Question number 6 of week 1. So based on that, you get the answer as 164.87.
okay,
So
sir.
last time also someone was there who told 164.87, something like 164. Unfortunately, originally among the options that were shared with you, option D was there, which was the closest. The value was 162 point something. So you can choose 162 because it is closest to 164.87. In that sense, you can choose option D, and that way it will be during, if it is a kind of assignment and you have to submit it, so it will be taken as a correct answer.
Oh, okay, sir. In theory, in slides, uh, actually, I want to know the calculation. How it calculated. So the method I want to know.
Okay, so the method is simple. That is equal to P naught e raised to power RT. So in that sense, they have taken R as, since it is 5%, so they have taken R as 0.05 multiplied by 10. So basically you have e raised to the power your 0.5, then whole multiplied by 100.
Okay.
Since they have already told that this is going to be an exponential growth equation, that is why.
Hmm.
There are few other questions today also, so you can try them and that will be easier.
Okay.
Fine. So we can start our session now. I hope my screen is visible. So I will start by introducing myself again because we might have some new joinees with us. So I am the TA allotted to this course on environmental science, which is currently being taught by Professor Sudha Goyal and Professor Shamik Chaudhary from Indian Institute of Technology, Kharagpur. And as for my current status, that I am doing PhD in civil engineering in IIT Kharagpur under the supervision of Professor Bradesh Kumar Dubey and Professor Makarand Madhav Bhangreka. So as a part of our TA-ship deliverables, what we will be doing is that every week on Tuesday from 6 to 8, we will go through a set of 15 questions, discuss them. You will be solving them. I will give you some time based on the question in that you will solve them. Then we will discuss about the solution. If you, in the meanwhile, if you have something to add from your end, you're always welcome to do so. Have some opinions of your own, and maybe preferably it can be an interactive session as much as
So
possible.
what is the answer of question two?
Question two, it is 164 point, question two of what?
Which of the following is considered as major environmental concern in terms of water quality? I think it is all of these.
So from where are you getting these questions? Because I like,
So you are mute.
okay, so from where are you getting these questions? Like I don't have the question bank from where you are.
सर वीक वन में क्विज जो है वहां पर है.
So this is the quiz that has been shared with you in the assignments, right?
Yes sir.
So you have to do it on your own, then the solutions will be shared with you. If I answer your quiz here, then that won't solve the matter. If you have
Okay,
something doubt regarding the concepts that we can work on, and we have these sessions as well, in here we can discuss that.
okay sir.
Fine, just give me a moment. Okay, fine. So we can start with the session now. Coming to question number one, which of the following is or are the major sources of air pollution?
All of these.
Yeah, so that was very simple. So I will quickly move to the next question. Which of the following can cause population density to fluctuate? So just a hint that there can be more than one correct answer in this question.
Migration,
Yes, that is one of the correct answer.
redrawing of city limits,
True. These two are the correct options. Then this is again a very easy question. Fill in the blanks type. What change?
in,
Sorry,
increased,
increase. Yes, very simple. Then in next question, again fill in the blanks type. This we have discussed in our previous live session. So you should be able to answer it.
pollution,
No, you see what they're saying? It should,
Contamination it is.
right, it is contamination because the substance, it should not be at concentrations,
yes,
yeah, not be at concentration or at concentrations above the background levels. So that should be termed as a contamination. For example, we discussed about different antibiotics present in the water bodies, or let's say different kinds of chemicals like refrigerants, all those kind of stuff. So these are coming under the category of contamination. Then again, a very simple question. This is
extinction,
true. So in here, while I was going through this question, this is a term that I came across for the first time, phylogenetic diversity. So I just wanted to share very briefly what I found on phylogenetics, what it is. And otherwise, I was going through these topics very quickly, and I saw that this is an entire domain. Those in our live session who might be from this kind life sciences or biotechnology or these kind of background, they might be better able to answer or have a much in-depth knowledge of phylogenetics. So basically, what it is that it is, you can say, a more advanced version of biodiversity. When I am talking, like I am asking you what is the biodiversity in your region, basically what we do is that we go out in a region, let's say if it is a forest. In a forest, we count what are the different species of trees are there, species of animals, birds, insects, all the other things. And then we count like how many of this species, how many of the other species. So that is a very simple way to account for the biodiversity. So you can consider phylogenetics as a much more evolved version of accounting for biodiversity, where what they do is that they also study how different species have evolved from by also considering the time span, right, from a certain time to current scenario, and then accounting for the entire biodiversity. And that typically includes they prepare a tree, which is called phylogenetic tree, and then they measure the length of that tree. Based on that, they denote it. But since it is a bit complicated, that's why I think this is not one of the most frequently used ways to denote biodiversity. So you can see here that phylogenetics is basically the study of evolutionary relationships among biological entities, which can be related to species, individuals, or even genes. In a certain organism, some genes is evolving through the passage of time. That is also accounted for here. And the basic answers or the questions that it asks is that what is the history or of the evolution or the relationship between different species, individuals, or genes? That is one thing. And what is the step by step how they evolved? So first what happened, then what happened, like that. This can be from a simple example. What I can think of is how the dinosaurs, they finally transformed into your either birds or some of the reptiles, like that. And then can I better describe the process of sequence evolution with a mathematical model? So in here there's a hardcore your emphasis also going towards modeling of this entire evolutionary process. So it is a bit complicated. Those who want to take a deeper look into this, have want to concentrate more on this area, they are always welcome to go through different research papers, different books which are catering to this particular aspect. So now we will move on to the next question. Which of the following can help in controlling the global warming?
A and B option.
Yeah, A indirectly, but B directly. So that is why if such a question comes to you and you have been clearly given that this is a single option kind of question, in that case, you will be choosing reduction in fossil usage because that is basically the direct, very evident that we is clearly responsible for reducing the global warming. Reduction in water wastage, that can be a very indirect branch. So can you please justify why have you thought of reducing water wastage as a step towards controlling greenhouse gas emissions?
But actually, when we draw more water in sea, the salination or saline properties reduce, which lower the temperature of water, sea water, and it helps in the the property of salt is to help uh, condense the glacier. The glacier doesn't melt. So if we add more water, the saline property will be reduced, and glacial melts and water level rises. And this is the form of global warming, I think.
I You are somewhere close, but not exactly to the point, I guess. Like this can be one aspect, but what I can remember is that regarding salinity, when I visited some hill stations, I saw that people who want to get rid of the snow quickly, so they used to sprinkle salt on that. So so salt helps actually the water to melt. So from that aspect, it doesn't really hits the target. More likely, like if you want to say you want to reduce the water wastage, so you can think in a way that water wastage, where is the major point of water consumption? Water consumption is happening in your homes in various industries. So I'm directly thinking about the point what the question is or the option is saying. So if I can reduce the uses of water there, so what I can do is that that water is not directly coming from rivers. That water is first treated in your water treatment plants, and in water treatment plants to treat that water, a lot of electricity, a lot of sometimes chemicals and other things are used. You have to also disinfect the water. For disinfection, you know that most frequently we use chlorine for that. Then, other than that, some of the more advanced ways is in your households, we are using ozonation, UV light, and all those stuff. So, all of these are very energy intensive, chemical intensive. So, indirectly, if you reduce the water wastage, you are reducing the water requirement. So, you reduce the amount of water that is to be treated. So, in that way, directly, you can say कि by reducing the water wastage, there can be some reduction in global warming potential, but that is just an indirect reduction. But a more direct and obvious answer will be reduction in fossil fuel usage. I hope that helps. So based on that, I have few points that I wanted to share. One is this: you must have come across the phrase biogenic carbon dioxide emissions. So anyone has an idea of what is biogenic carbon dioxide emission, or where people use or why people use this particular terminology? So there are, if you want to take a look at carbon dioxide emission in this particular figure, I hope it is visible. You can see that carbon dioxide can be emitted from two sources. One is here on the right hand side, you can see fossil fuels, where the plants and fossils, they have been kind of stored inside Earth's crust for a very long time, and then we are mining it out quickly and then burning it, and that carbon dioxide is going to atmosphere. So the fossil-based carbon dioxide is called non-biogenic carbon dioxide. While biogenic means you can get an idea that bio means it is talking something about biological. So biological, what it means to say that this carbon dioxide is somewhat directly or indirectly related to biomass. And what it tries to imply is that if you, for example, you are burning the agricultural residues after harvesting your crops, you have collected a lot of husks or stalks. You collected them and burned them in some place to collect the energy. So what sometimes people do is that they assume that while burning that particular biomass, the carbon dioxide that is released into the atmosphere, it is the same carbon dioxide that the biomass has collected in itself while it was growing. So in that sense, they say that whatever it collected in the initially, the same it released back into the atmosphere when it was burned. So that is why these kind of emissions are called biogenic emissions, and often less importance are given to them by thinking that these are kind of carbon neutral, because whatever they are consuming or incorporating into their plant biomass, the same thing is sent back into the atmosphere when they are burned. But is it a correct way to do so or not? That I would like to have your opinion on. Like, what do you think? In many people, you must have come across the term life cycle assessment and different things, where we try to estimate what is the global warming potential or carbon footprint of different processes. And very often, what people do is that they ignore biogenic emissions. So they don't account for the environmental impacts caused by those biogenic emissions or global warming. So what are your opinion? Should we go ahead through this approach, or should we adopt a different kind of approach, and why? Any thoughts? Like, it is a very simple question.
So we have to reduce our needs. We have to rethink, reuse, reduce, and recycle the things. Therefore, and in that way, we can reduce CO2 emissions.
No, that is fine. But like, I hope you can understand what is biogenic CO2 emissions, what are included there.
Yes.
Is that clear? So biogenic CO2 emissions means it is coming from some biological material that can be your agricultural residues, wood, or your organic fraction of municipal solid waste and all those stuff. So what I am trying to say is that
Basically, it is all adding up to the CO2 emissions, be it biogenic or non-biogenic.
true,
It is
but
ultimately adding up to the global warming, no?
yeah,
And
absolutely
municipal waste incineration or agricultural waste burning is not a very environment friendly because it adds to the CO2 emissions. So it has to be counted.
true. But what if someone gives you a logic, then it has already absorbed. It also, like, for example, you burnt something about wood. At the same time, you planted few trees who will start absorbing carbon dioxide. So what can you answer to this particular statement? Like, although you are burning leaves and trees and woods,
So
but
we
at
can bury it so that it is a carbon sequestration is a term.
hmm,
So before in ancient period, we generally buried all the things. We cannot burn. So the carbon will be uh,
no, that is true.
not escape
Absolutely.
in the environment.
That is the best case scenario. But I'm just asking, let's say you have been given with the only scenario that this is a few pieces of stubble or agricultural residues or husk, and you have to burn it. Just I want to know, like, if you are going to ignore the environmental impact of the carbon dioxide that is being released from those biomass, whether it is actually right, if yes, and if not, why? Because people very actively, in fact, we have also done it in few of our papers to see how it compares with other studies. We have ignored such kind of emissions. But I also believe it might not be the correct thing to do to ignore them. But I want your opinion on why it is not the correct way. Because others can give you the logic, like if you have a piece of wood or rice stalk or wheat stalk, the same stalk, the carbon that is present there, that carbon has been captured from the atmosphere. And then when you burn it, you are releasing the same. So again, in the next cycle, if you plant new crops of wheat or rice, it will again absorb all those carbon dioxide. So it is kind of carbon neutral. This is what people say. So what is your opinion on that? So people say that this is carbon neutral, these biogenic CO2. You can see that this loop here, CO2 is coming, and then when you are burnt, it is again going back to the atmosphere, again it is coming. It is forming a cycle. But is it right to ignore the impact of this carbon dioxide?
No, sir.
Any thoughts, like why?
So whatever we grow, whatever we burn, CO2 is always released. So
CO2 is always emitted.
yes.
It's
Yeah,
also
but
adding up to the pollution, no? Air pollution factor.
true, it is adding up, but it is also the absorbing at the same time.
No,
because
but
the
the concentration when it is burned is definitely more in the air than when, over
absolutely
a time it will be trapped.
true. So that
And when it is
concentration
released
point,
immediately, it will be in a high concentration.
true. So that concentration point is one major thing, that when it is absorbing carbon dioxide, it is occurring at a more sustainable and a like same kind of pace. But when you are burning this biomass, the concentration of the CO2 being emitted and the rate at which it is being emitted, that is absurdly higher than the rate at which it is being captured. So that is why it, ideally speaking, it should not be ignored. But since different people are ignoring it and then reporting some carbon footprint values, so if, like, say, you are an industry and you have competing two, three industries, and they are calculating the carbon footprint by ignoring the biogenic CO2 emissions. So just for the sake of competition, you also will, let's say, calculate two global warming potentials. One, by ignoring the biogenic CO2 emission, and secondly, by considering the biogenic CO2 emissions. And if you consider the biogenic CO2 emissions, then the right thing will be you have to also consider the environmental benefits of the carbon dioxide that is being captured by your biomass in the same time. So that is why sometimes or most of the times people ignore this. But ideally it shouldn't be, because when you burn something, it is happening, the CO2 is being released in a much concentrated manner and in a much faster way. So that is why. So I hope that was helpful. So now we will move on to the next question, which is, as compared to arithmetic increase method of population forecasting, how does the value coming from geometric increase method is?
I think it is C, higher than B.
True. So the C value is correct because it is kind of the population is getting compounded. So that is why it is
So
higher.
will you please elaborate what is the difference between linear and geometrical increase?
If you look at the formula in linear increase, it is P is equal to P naught into, sorry, plus that NT, something
Yes.
like that, na? So that
Yes.
is the algebraic formula of a linear equation. Y
Okay.
is equal to mx plus c, if you
And
try to plot it.
okay.
And if you look at the geometric mean, that this geometric increase, I think it is P is equal to P naught into 1 plus RT raised to the power R, sorry, 1 plus R raised to the power N. We'll just write it here.
So in simple language, you please tell me now that in my notes I have written natural growth is growing by fixed amount each year.
Yeah, if you look at this equation only, it is very simple. You can understand that.
Okay. So here in linear growth, number of people increased, and in geometry growth, percentage increase. I think.
Yeah, it's like that only. What is it? RT or what you use? T, na? I guess. This is the linear form, and the other is equal to P naught into 1 plus R
Upon 100.
raised to the power P.
Yes.
Yeah, R, that depends. If R is given to you in the form of fractions, like you can have R in the question come in two forms. If someone has given to you R as percentage, then you, this formula will become R is R by 100. If someone has given to you R as 0.05, but no percentage is given there, then you have to simply write 0.05 here, not divided by 100 again.
Okay.
Okay, so that is one thing. So I will just write it R here. So what was the question exactly? How is, so you wanted to know why it is linear. So in here you can see that we, linear equation is most basic, in a most basic way what we have been studying from our childhood is y is equal to mx plus c, where we have two variables, one is y and one is x, m is the slope and c is constant. Same way in this particular equation you see our unknown is p, this is acting as y. P naught, it has already been given to you. What is the initial population? So that becomes our constant C. N T. N is the slope, or in case of N, it should be, I think, RT, rate at which it is increasing. So R is your M, slope of the line, and X is your unknown, not unknown, the thing that is varying, the variable that is time. So if you try to plot it again, so if you have a linear plot and the population is, let's say, increasing, this is your time, or X, which is varying, and in here you have to find the population. So that is, and this slope of the line, that is P by T. So this is your M. Is it understood why this is a linear equation? And similarly, this particular, and again another point why it is linear is because Y is varying with X at a constant slope. But in here, this is not a direct correlation. This is not a form of linear correlation, it is rather a form of geometric equation. So I will just Google it and show it to you, that will be easier. Geometric equation plot. Yes, that is easy. So I have already shown you this is the linear plot. That is clear. Just remember this trend of how the population is increasing. Now I will show you how a geometrical plot it looks like. Okay, so can you see this particular plot? See these dotted lines.
Okay.
So you see that in the linear equation, the increase is kind of constant. It tends to be a straight line. But in here, you see the population is first, it is growing like this, and then the population is increasing all of a sudden. Assume that this is the population, y-axis is population, and t-axis and this x-axis is time. So if it would have been a linear plot, then what would have happened? Just see my cursor, this cursor here. I am assuming these are linear plots. Then let's say in second year my population became this. Continuing this line, in third year the population would have been a bit lower, and in fourth year the population should have been somewhere here, right? Just where my cursor is. But in truth, where it is, in at truth it is much higher, near 8. So that is why geometric equations or geometric population growth, it is, the rate is higher than that of linear, because linear means a straight line. If you draw a straight line from here, the straight line will go somewhat like this. I can take a screenshot of.
Geometric equation is generally denoted by 2 to power, no? So it multiplies that many times, and
Yes,
the
so
growth mode.
that is why the growth is more. And if you want to take a look at it pictorially, this is the best example. Just paste it here. Okay. So this is again, so if it would have been your linear right from the start, then this population growth curve, it would have been somewhat like this, following these two lines, somewhat like this. But since it is r to the rate is r to the power t, it is in the power, so the rate of increase in population is much higher. So linearly, it should have been somewhere here, but you see geometric estimate, it is higher. Then again at fourth year, it is even higher. In fifth year, it is much more higher. So I think it was helpful. Is it clear?
Yes, sir.
Okay.
So will you also show the graph for this exponential growth?
Okay, so exponential growth is even steeper. It is similar to geometric, but if you look at the equation, then you will understand. The graph of exponential, you can see I just pasted it here. It
Yes.
looks somewhat like geometric, but the rate of increase, it is even more than that of geometric. A very easy example is you write all the equations like for logarithmic, exponential, geometric, arithmetic increase, incremental arithmetic increase. Assume some same value of P naught, whatever it is. Assume the same value for R and assume the same value for T for all the cases and put it in the equation. You will see that the highest value will be for exponential, below that it will be geometric, and then below that it will be arithmetic increase method.
Okay.
Right. So now this is a question where you have to estimate the population at the end of 10 years using a geometric growth method. So you can have about 10 minutes, 5-10 minutes to answer this.
सर ये 1.05 की पावर 10 को कैसे मल्टीप्लाई करेंगे?
इसके लिए आप you can use
सर
calculator
यू
for that.
म्यूट.
Okay, sorry. Okay. So you can use your scientific calculators or the gate calculator for that.
ओके सर.
Is it 3258?
Yes, the correct answer is 3258. So I can only wait. Yeah, the correct answer is 3258. So please let me know if anyone has faced any issues. The formula to be used is the same we have discussed in the previous slide. P0 or P naught. This is the formula to be used where instead of R, you have to put your 5. In case of T, you have to put 10, and then P naught is your 2000. So solving that, you will get 3258. Now, if you have been able to solve this question, the next should be even easier. Now you have to choose exponential growth method. Has anyone able to get the answer? You can use the chat box also, whatever suits you.
Is it 4136?
Not 4136, not 4136. I will also check.
Three two nine seven.
3297 might be the correct answer. I am just calculating the verifying. Yes, 3297 is the correct answer. So Gautam Priyadarshi has also got the same answer. Great. So this is an example that we were just discussing in the previous slide that assume the same values, and you will see that your exponential growth, this will have higher population forecast than your geometric growth method. So that is clear. In geometric growth, it was around, what was the value? 3258. And now it become 3297. So let's see in the next question. This is a different question where the current population has been shared with you in 2023. Growth rate per decade has also been shared. You have to predict the population of the town, pot 2043. And you can use your that one arithmetic progression method.
$76,000.
Yes, 76,000 is the correct answer. So I think most of the numerical questions are over. Yes, now we only have some basic questions left. Yes, 76,000 is the correct answer. Now in next question, you have to choose an option which is suiting for what is natural capital. Very simple. If even if someone tries to guess this, they might most probably guess it correct.
It is B, natural service plus natural resources.
True. Oh, great. So after this, we have which are the following are the characteristics of ecopolis. Again, you might be able to guess it correctly. Ecopolis.
It is 1, 3, and 4.
True. 1, 3, and 4 are the correct answer. Now, this is an interesting question, not that interesting, but might be a bit important. So this is based on an iPad model, and you have to choose which one is what.
It's A.
Yes, A is the correct answer, where impact is what you have to calculate. So the impact can be carbon dioxide emissions. P is your population. I guess what is P? Yeah, population. So IPAT is there. 2 is your 1, that is number of cars. A is your affluence. So affluence is how much that vehicle is being driven. So miles driven per hour, and technology, which varies from type of vehicle to vehicle. So that is fuel burned per mile. So that is why option A is the correct answer. So quick go through this. I is impact, P is the population, A is your consumption per person or the consumption by the consumer, and T is the technology or how much the fuel or something is being burnt. Now, this is again a very simple and last question for today. You have to calculate the energy performance index based on this. So it can be calculated in terms of per month only. Per month, per meter square area. after this, we have a couple of other questions I can see. So what you can do is the formula of EPA is simple. It is your power consumption per unit area. So your power consumption is what is the 250 kilowatt hour per month. This entire thing is to be divided by area. What is the area? 600 square feet. Convert that 600 square feet into meter square. So it will become 55.7 and you will have the answer as 4.49 kilowatt hour per month per meters square. So this is the correct answer. So now we will go through a few other questions. Yes. So in an ideal world, when would be the Earth overshoot day?
The 1st December.
True. So it is 31st December because it is like this that whatever is the demand for resources on planet Earth and whatever it is being generated, so just at the last day of the year, it is being consumed. So that means the Earth is generating whatever you need for an entire year and it is not falling short. Now, coming to the next question.
Is it C?
C, let me see if it is
B.
C.
Waste.
Raw material and waste.
Not exactly. Like these are all indirect. These can be indirect answers, very, very indirect. But there is a much more direct is your demand and supply. So the thing is, ecological footprint measures demand and supply of natural capital. Why it is like that? The thing is, if you talk about what ecological footprint basically is, it is how much a person can consume as compared to what it is being generated or renewed by the planet each year. So you have to subtract these things. What is being renewed or what is being generated by Earth, that thing minus of what is being consumed. So that is why it stands more like a demand by artificial human activities. And supply is how much of natural capital that you saw in one of the previous questions, natural resources and all those stuff is being provided by Earth. So this thing has been taken care of in ecological footprint. Okay, so coming to the next question. Now this should be again a very simple question. You have already answered this.
Floor area
True.
of the
So
building.
area is the correct answer. So let me see if I have any more questions left to discuss with you. No, these were the questions that we had to discuss today. I will quickly go through all the questions again for those who might have joined a bit later. So the first question was, which are the following is or are the sources of air pollution? So in here, forest fires, volcanic eruptions, waste incineration, all of these are the sources of air pollution. Then the reasons that can cause the population density to fluctuate. So it can be redrawing of the city limits along with migration. Then when will the CO2 become the reason for global warming? If the CO2 concentration increases, that will cause global warming. After that, what is a substance called if it should not be at concentrations or at concentrations above the background levels? It is contaminations. Either that thing should not be there, and if it is there, it should not be at levels above the background level of its concentration. So it is contaminant or contamination. Then death of the last individual in a species is called extinction. Very simple. Based on that, we discussed what is phylogenetic. It is a study of evolutionary relationship among biological entities of different species, individuals, or genes. It is, you can consider it kind of a much more advanced way to look at the biodiversity of any area by answering particular questions which talks about how the evolution is taking place, what is the history, and how the evolution of different species they link with each other and depend on each other. Along with it, the sequence of evolution step by step, as we can see in various figures of the human body, how from ape we became human beings, something like that. Then it also, along with all these things, Mathematical models have to be created to justify these models, to justify these sequences and evolution models. So much more advanced version of simpler biodiversity. Then, which of the following can help in controlling global warming? So the correct answer here is reduction in the fossil fuel usage. After that, we talked about biogenic carbon dioxide emissions, which are basically the emissions that can come from combustion of harvest or any biological matter to say. In this particular diagram, you can see that any biomass, if you burn it, the CO2 emitted is called biogenic carbon dioxide because it is thought that the same CO2 will be at some point of time again absorbed by the plants and assimilated in them as carbon in their stem, twigs, and various other parts of that particular fauna. On the other hand, fossil-based carbon emissions, these are called non-biogenic carbon dioxide emissions, and they are not ignored when you have to calculate the global warming potential or carbon footprint. On the other hand, biogenic carbon dioxide emissions are very often ignored during carbon footprint estimation. After that, we discussed about arithmetic increase method and geometric increase method, which of these shows or estimates a higher value. So geometric increase method estimates a higher population than arithmetic mean method. After that, there were a few questions on estimating the population, first using geometric growth method, where you have to use this particular formula, and the answer you will get is 3258. 3258. Yes, I guess this was the answer. Then after that, using the same values and but adopting an exponential growth method, the answer increased to 3297. After that, in this particular question, the population is to be predicted through arithmetic increase method, and the answer was 76,000. Then what is natural capital? Natural capital is the sum of natural services and natural resources. Then what all are the characteristics of ecopolis? Ecopolis includes waste utilization, reliance on renewable energy only, and also adopting circular economy principles. Then this is a match of the following type of question suiting IPAT model where impact is associated with carbon dioxide emission. Population clearly means number of cars. Affluence means how much you've used it. So miles driven per car. Technology based on the type of car. So what is the amount of fuel burned per mile you have driven? Then you have to calculate the energy performance index, which is in, you have to calculate the data in kilowatt hour per month per meter square for an apartment having 600 square feet area and an average consumption of electricity 250 kilowatt hour per month. Use this formula, power consumption divided by area, and you will calculate the value to be as 4.49 kilowatt hour per month per meter square. Then in next question was what should be the ideal Earth overshoot day? So it is 31st December. So that implying that whatever resources is being provided by planet Earth naturally, that is sufficient to cater for all the human activities because people are using it just in the last day of the year. Again, if you use it next year, so you will again have a suitable or appropriate amount of resources to cater for the next year's demand. Then the ecological footprint basically measures the demand and supply of natural capital. After that, EPI we have already discussed, the average annual electricity usage, and also depends on floor area of the building. So these were the questions that we have discussed today. I hope it was helpful for you. If you have any doubt or any points to add, you're always welcome to do so.
Sir, is it carbon footprint and carbon emission and carbon footprint is the same thing?
Yes, carbon emission and carbon footprint are considered as the same thing because when you talk about carbon emission, the reason why you are talking about it is basically due to global warming and whatever gases are being released, for example, nitrogen, dinitrogen monoxide, N2O, which is also called as, I think, nitrous oxide. Let me see. Yes, nitrous oxide. So it is also a very dangerous global warming greenhouse gas. So all of these are considered as carbon footprint, and carbon footprint is the same as global warming potential and all this stuff. Any other doubt? Like, I think the sessions will be more interesting when we will start discussion on particular topics like solar energy, hydel, and other those aspects. Because as of now, I think it is going into a more generalized way. So in the next couple of weeks, I think we will be having much more interesting questions and topics to discuss. Just a disclaimer, this session will go from 6 to 8 p.m. on every Tuesday. And as of now, in case if you don't have anything else, you don't to add or you have anything to ask, it is not mandatory to join the session till 8 p.m. You can leave whenever you want.
Hello, sir.
Yes.
What will you say about the what sustainability in normal terms, normal words?
Sorry, there's some noise in the background. Can you come again?
What will be the meaning of the sustainability?
Sustainability.
Yes.
So sustainability is a very basic definition. Like what it means is that you have to use the resources, natural resources that is being provided to you in a manner that you don't risk or harm the requirements of your future generation. For example, you have some needs from planet Earth today, whatever resources you need. So it should be maintained in such a way that you have to also think about and cater to your future generations that they also will be using those resources and you are keeping sufficient and ample of amount for them as well. So that in a very crude way, that is the definition of sustainability or sustainable development.
Second is that what is the meaning of spillovers?
Spillovers. So
Yes.
I thought that someone else also asked it. So spillovers, from where are you getting this term? Spillovers. Like from which particular topic?
So it is in second week course.
Regarding that solar energy and all?
Spillover is the things we are export or import from other land, na, other country, and it create pollution like
Okay,
export of pesticides, weapon, drugs, plastic, cross-border pollution,
okay, I will just Google it still.
negative impact of crime, weapons, war and battles. So it all cause high carbon emission in other countries also.
Okay, so the definition I got, environmental event caused by one and the one resulting in consequences of act. Yeah, something like that only I also got. I simply Googled it and it says that there are different firms and all, whenever they have some transactions between them, some regulations are changing. There are some new investments here and there or decline in sales. So all those things are maybe if those things are causing pollution, then that is called spillover effect. Wait.
Next is the in general terms. What is the urban sprawl?
Urban sprawl, it is basically an increase in your density in the urban areas, no population density. Not that, or just give me a moment. Urban sprawl. By low density residential housing, single use. Okay, sorry. So urban sprawl means, for example, you can see that in a certain area, a lot of like you have a city and it is expanding in a way such that in the neighboring areas you initially had some tree line, some green cover. All of that is being now converted into urban region. So that expansion is called urban sprawling of cities and towns.
Next is that what is the green ball?
Green wall. So green wall is basically what some people do is that in some concepts, in green walls, they prepare a tree line, and that tree line is of maybe let's say you are living in colonies. So after your colony, there is a tree line. After that, again a colony starts, and then after that, there is again a tree line. So the tree line is basically a green wall. So it also helps you provide some tree cover in your vicinity, and that helps in reducing global warming potential and all those stuff advantages to that.
Okay, thank you, sir.
Thank you.
Next is that then do you have any calculation? Then the how is the percentage using in India in the fossil fuels, hydrocarbons, nuclear energy, in hydro? Any percentage regarding India?
Haha, like there are various websites which give you this. Let me just Google it. I use one of the frequently used ones. Energy mix of India, right? Energy mix of
Yes,
India.
yes. In the what is the difference between the other
Right.
developed
Like one is that there are different government websites like Niti Aayog. I will just quickly open it and see. Okay, so I have got something. Right. One thing I got was that. Yes. Again. Okay, so you can see my screen, right? So this I have opened the site of Niti Aayog in Government of India. So in here you can see that most of India's energy demand is coming from coal, 57.6 or 57.7, followed by oil and then gas and then your hydropower. But this is your entire primary energy demand. If you want to look at electricity, then this is another website,
थोड़ा सा
IEA.
ऊपर स्क्रॉल करना जो साइट थी ना
Hmm.
ओके डन
For some reason, this site is not opening. So this IEA.org, this is again another website where you can type the names of different countries and it will show you how much is the fraction of solar, hydro, coal, oil contribution to your electricity generation and different things. So this is being very frequently used by in people in different presentations. So for example, I will just find something here. Here you can see that it has shown you the transition of different fuels contribution to your energy demand across different years from 2000 to 2020. So they provide you different kinds of graphs that can help you understand how this fuel consumption of different countries are also varying. So I will open another one. Iceland. Electricity mix. So this is for Iceland, and here you can see that what is it? 67% of their electricity it is coming from wind, solar, and something else. 0.5% from biomass, 20% are from hydro, 10.5% from your oil, and even less than that from coal.
this is the energy generation data.
This is what?
This is the energy generation
Yes,
data.
energy being supplied to Ireland. That energy use, you can say.
Okay.
So how we produce electricity from biomass?
Same way as coal. Like there are different ways. Basically, what we do is uh, for electricity generation using coal, basically we burn the coal, the heat is generated, that heat will produce steam by boiling water and all the stuff. That pressurized steam, it will go on to rotate the turbines, and those turbines will then generate electricity. In the same way, you burn the biomass will again do the same thing. They will generate heat. That heat will boil water. That water will generate steam, and that steam will rotate the electricity. The difference is biomass may generate less heat than coal, but maybe you have a lot of biomass, so you can substitute or reduce some amount of coal demand. Otherwise, what happens is that there are different technologies which can convert biomass into other fuels like your hydrogen into methane. So you can also burn them and generate electricity in the same way. So basically, electricity is generated traditionally by burning is you generate steam, and then you that steam will run the turbine, and then you uh, generate the electricity. So that can be one thing. So the steam can be found by either burning methane that is being generated from biomass or hydrogen that is being generated from biomass. So these can work. Some people, in fact, what they do is that after burning, they have produced steam and all those stuff. But after burning those all gases that are being produced, carbon dioxide and other gases, they in fact sometimes use those gases as well to rotate the turbines. So whatever is needed to rotate the turbines, that is being done to generate electricity. Was it clear?
Thank you, sir. Yes, sir. It is clear now.
One more question. Then we are learner of the environment science.
Okay.
Then we are submitting the assignment of week one. Then
Mhm.
we are not getting the result. How many questions are?
Okay, okay. So I think for these particular things, you can write to NPTEL because they deal with all these things like when they should release the results and when it is visible to the applicants. So what the faculties here do is that before the course starts, they share or right before after the course starts, they share all the course materials, all the question papers, assignments, everything with NPTEL. Then NPTEL takes care of that, manages and releases them step by step to the participants. So I think if you mail to NPTEL authorities, they will be better able to help you.
Okay, sir.
Sir, in November, there is a paper for this course. So is it is subjective or objective?
The paper for this particular course, it will be MCQ based only. Questions which are will be shared to you through assignments and what we discuss in these live sessions. Similar pattern of question paper you will have in the finals as well.
Okay, sir. Thank you.
So we have any system or any preventive data? Then where is any flooding storm can be moved in particular area, so we can identify it or we can get the message from the sites.
What kind of data? Can you please come again?
Like there's the in last days the Bayanite is the suffering from the rainwater. So how we can the get data before then the rainwater is coming by different area, particular area.
Okay, so the rainwater is coming from which area? It's asking.
Rainwater, storm,
Stormwater, okay. Like there should be
any,
Indian
any,
government sites which share
any
these
type
things.
of any type of the disaster.
Okay, so basically what you want to know is how much water, let it be rainwater, stormwater.
No, 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 no. I am saying that then how can get the message if any disaster is coming in particular
Okay,
area?
okay. So this is being taken care of by what is that called? Disaster management team in India. Disaster management. Like for example, in our like this is called National Disaster Management Authority (NDMA).
Yes, yes.
So what happens is that I personally experienced it, and many of you must have also seen it. Like right before some severe storms, we often receive some messages on our mobile that we might face this kind of storm, so prevent going outside and all this stuff. So NDMA does all these kinds of things, and you must have also seen that uh, different alerts are being also provided in various coastal areas before high tides and all this stuff. So this thing has been taken care by NDMA. So this is not exactly my line of work or my area, but I have come across some people or some instances where I've seen these things and some courses also that we have taken on disaster management. So these kind of alerts are being provided by the authorities before any such storms or other disasters. बाद में